All right, so next one says the gazebo in the photo is built in the shape of a regular octagon. So again, if you don't know what an octagon is, you can think of an octopus, and hopefully you know what that is, or you can just look it up online, right? Octagon. Each side is 8 feet. What is the approximate area? Okay, so again, I'm not going to draw the octagon. What I'm going to do is draw like this. I'm going to draw a bottom side, this side, and this side, and I'll put the center. All right, this is how I typically do this. Now, an octagon does have 8 sides, n equals 8. Okay, now it tells us that each side is 8 feet long. Okay, so the problem with an octagon is that these triangles, once I draw these radii in, these triangles are not equilateral. So this is not an 8, 8, and 8 situation. So how am I going to find the area of this triangle here? Well, I'm going to use trigonometry. Okay, now first off, I'm going to find this central angle. So remember, you take 360 and divide it by the number of sides. There are 8 sides, right? It's an octagon. So 360 divided by 8, that is 45 degrees. So each of these is 45 degrees. And then I'm going to draw in the apothem. If you remember, the apothem is that height going to the side, okay? And what this apothem does is, because these radii are congruent, this is an isosceles triangle. So I do know that this side and this side are congruent. So this apothem actually bisects the bottom side. So now this and this are congruent. So this is 4 and that's 4. And it also bisects this top angle. So if you take 45 and divide it in half, you get 22.5 degrees. And now I can use trigonometry to find either the apothem or the radius. And it doesn't matter what you do. I could care less, okay? It's up to you. So let's go ahead and let's just find the height. Let's find the apothem. How about we do that? I think this is not how I was going to do it, but I figure let's just use the old school formula, right? So here's my angle. So 4 is going to be the opposite side. The radius is the hypotenuse I don't care about. And then the side I want, this height, call it x, that's going to be my adjacent side. So opposite and adjacent is tangent. So this is a tangent problem, right? So tangent of 22.5 degrees equals the opposite side 4 over the adjacent x. And when your variable's in the bottom, you do the old switcheroo. So x equals 4 over the tangent of 22.5. And I will type that into my dinky calculator. Make sure you're in degree mode. 4 divided by the tangent of 22.5 is, and I'm going to round this out to a couple decimals, right? Looks like I'm going to do 9.65 65685. Okay. Again, I just try to be, as exact as possible. Don't round early. So now, once you find that height, now you must find the area of the entire triangle. So again, think about this. It's the area of the entire triangle that has a base of 8 and a height of 9.6568. And then you're going to multiply that by 8 to find the area of the octagon. So to find the area of a triangle, we're going to use the old formula, 1/2 base times height. And then to find the area of the octagon, we're going to take 8 times the area of the triangle. So I'm going to combine all that into one in my graphing calculator. Let me take a picture. Okay, so let's go there now. And again, you don't want to round early because again, you'll be decimals off when you have to type this in. And it says whole number, so that's trying to bail you out. So we're doing 8 times 1/2 times my base was 8 times my height is 9.65685. And I got 309.0. The 0 leaves the 9 the same. So this answer is 309. So we're doing 309. And again, it's feet, so we're doing feet squared. Now, when I actually did this problem before this video, I used I found the radius, and I used the 1/2, BC sine of A formula, and it still worked out the same. All right, so whatever you want to do is fine. Whatever you want to do is fine. All right, great. Next problem. So it says replacement glass for energy efficient windows costs $5 per square foot. About how much will you pay for replacement glass for a regular hexagonal window with a radius of 2 feet round to the nearest cent? So again, here is my picture. Again, I will not draw the entire hexagon. I'll just draw the bottom side. I'll draw the two edges. Here's my center. Here's my radii. Okay. So it tells me that the radius is 2 feet. So that's this side and this side. And I can find the central angle by taking 360 divided by 6. That's 60 degrees. And now I'm in business because I have side, angle, side. To find the area of this triangle, I can use the formula 1/2 B C sine of A. And now to find the area of the hexagon, I'm going to do 6 times that. 6 times 1/2 times 2 times 2 sine of 60 degrees. All right, so let's find the area of this hexagon. 1/2 times, or 6 times 1/2 times 2 sine of 60. Let's clear all this out. Remember, if you delete all that, you have to go back to the wrench and change it back to degrees. So 6 times 1/2 times 2 sine of 60. And that's going to be the area of one of these panes of glass. 10.392, blah, blah, blah. And that's going to be in square feet. But now, for every square foot, it's going to cost $5 to replace. So we need to take this and multiply it by 5. So I'm going to put a times 5 in front. What this is going to do is this is going to find me my replacement cost. And when I did that, I got 51.96 to the nearest cent would be where the 6 is. The 1 leaves the 6 the same. So this would be $51.96. So you don't have to put the dollar sign, 51.96. All right. So when they give you the radius, life's really good. All right, last problem here. Okay. The polygons are regular. Find the area of the shaded region. Round to 1 decimal. Oh my goodness gracious. So we have a pentagon inside of a pentagon. So we have a small pentagon and we have a big pentagon. So the idea here is to find the area of the shaded region, you need to find the area of the big pentagon and subtract the area of the small. And that's what we're going to do. All right. So we can use uh, the same process for both pentagons. So I'm going to do that right here. So let's start with the big one. So again, here's my bottom side. There's my 2 sides. Here's my center, radius, radius. You give me a side of 8 centimeters for the big pentagon. Now again, I can't use equilateral triangles. This is a pentagon. Pentagon has 5 sides. But I know that these 2 radii are congruent. So I can use that whole central angle apothem idea. So what is the central angle? Well, 360 divided by 5, because pentagon has 5 sides, is 72 degrees. So that central angle is 72. So then let's draw in that apothem, perpendicular. It splits these into 2. 72 divided by 2 is 36-degree angles. So 36-degree angles. And again, it splits this bottom side into 4 and 4. And now again, you can find the area of this triangle however you want to. I am going to find the apothem and then use the 1/2 base times height formula. So if my 36 degrees is up here, again, I'm sorry, it gets kind of small. 36 is here, so 4 is my opposite. The hypotenuse is the radius, I don't want it, and then x is my adjacent. So this is a tangent problem. So tangent of 36 degrees equals the opposite 4 over the adjacent x. And I do the switcheroo, and x equals 4 divided by the tangent of 36. 4 divided by the tangent of 36. I'm going to round this. This is 5.5 0 553. Okay, so that's my height. So then to find the area of one of those triangles, so the area of one triangle would be 1/2. The base is 8, and the height is 5.50553. So to find the area of the big pentagon, I need to take 5 areas of the triangles. So let's do that right now. So we'll put a 5 in front of that. So we're doing in Desmos Graphing Calculator, we're doing 5 times 1/2 times my base times my height. And I got 110.1106. And I'm going to leave that alone. So the area of the bigger pentagon is 110 point, oh, sorry, 1106. So we're going to follow the same process for the small pentagon. So uh, I'm going to go to here, right? It's the same shape, so we could draw the same picture. It's going to be the same equation, except instead of using 4, we're going to use half of 6, and half of 6 is 3. So the tangent of 36 degrees, again, every pentagon has the same central angles as at their triangles, is going to be 3 over, let's call it y, all right, just for, kicks. So again, y, the apothem of the small pentagon's triangles, is going to be 3 divided by the tangent of 36. And again, I'm looking at the small pentagon now. And when I type in 3 divided by the tangent of 36, I do get a apothem, or a height, of 4.129 15. Okay? So then to find the area of one of those triangles, we're going to take 1/2 times 6, which was the base given to us in the small triangle, times 4.12915. And to find the area of the small pentagon, we're going to take 5 times the area of one of the triangles. So what is the area of the small pentagon? Well, let's go do that now. So I'm going to take 5 times 1/2 times the base, which was 6, times the height, which we found to be 4.12915. And I got 61.93725. So that's the area. So 61.93. And to answer this question to one decimal, all we're going to do is take these two numbers and subtract them. So if I go back to my Desmos graphing calculator, I'm going to take 110.116 and I'm going to subtract 61.93725. And I got 48.17. Again, to the one decimal, the 7 makes the 1 become a 2. So the answer here is 48.2. And they're in centimeters, so that'd be centimeters squared. Okay. So again, like I said, lengthy to explain. Hopefully it came out okay. And use your best to do these problems on your own. And if you have any questions, just feel free to ask. All right. Thanks for watching.